Okay, hello. This lesson we're going to be looking at finding the turning points and intercepts of quadratic equations, and then we'll start to use those to sketch. So, as you may remember, to find the turning point of a quadratic equation, like we're being asked to do here, we need to find the two x-intercepts and then find the point halfway between those to get the x value for the turning point. Then we substitute that back into the original equation to find the y value of the turning point. So if we're going to do this, we know that when we're finding x-intercepts, we set y equal to 0, so we get 0 is equal to x squared plus 6x minus 16. Now we're looking for factors of, now to solve this, we need to factorize. So we need to find factors of minus 16 that add to give positive 6. That's going to be plus positive 8 and negative 2. So we'll get x squared minus 2x plus 8x minus 16. And now we can take out the common factor of x from the first two, so we'll get x minus 2. And the common factor of 8 from the second two, we'll get x minus 2. And then we complete factorizing by moving the x minus 2 at the front. We'll get x minus 2 times x plus 8. Now this is equal to 0, so we can use the null factor law. So we can say by null factor, x take away 2 equals 0, and x plus 8 equals 0. And so x equals 2, x equals negative 8. So these are our two x-intercepts. So now we need to find halfway between these 2 points. So we can say 2 plus negative 8, all divided by 2, will give us minus 6 divided by 2, which is negative 3. So the x-coordinate of our turning point is negative 3. Now I can sub this into our original equation. Sub x equals negative 3 into our original equation to find the y value. Into y equals x squared plus 6x minus 16. And so when we do this, we'll get 3 squared plus 6 times 3 minus 16, which will be 9, plus 18 minus 16. And when we work this out, it'll be 27 minus 16 is 11. So our overall turning point is going to be turning point will be at minus 3, 11. That's it. All done with this question. All it wanted us to do was find the turning point, and we did that. Okay, so in this question, we're being asked to sketch x squared plus y squared plus 2x minus 35, showing the turning point and the x and y intercepts of this. So, first things first, we'll start with the x-intercepts. So, to find the x-intercepts, we set y equal to 0. So we can say 0 is equal to x squared plus 2x minus 35. And now we're looking for factors of 35 that will add together to give us positive 2. Well, some factors of 35, we could have 35 and 1, or we could have 7 and 5. And if we do positive 7 and negative 5, then that will give us positive 2. So I'm going to skip over the factorization process because this is a long question already. So when we factorize it, you should end up with x plus 7 times x minus 2. X minus 5, apologies. I encourage you to check this, try this yourself just to make sure that it works. So now we've got 0 is equal to two things that are multiplying. That means we can use the null factor law. So by null factor, we get x plus 7 equals 0 and x minus 5 is equal to 0. Then we solve both of these. We get x is equal to negative 7 and x is equal to positive 5. So these are our two x-intercepts. So if we want to find the x value of the turning point, which I'm going to call TP subscript x, we add these two together. So we'll do minus 7 plus 5, and we divide it by 2. It doesn't matter what order we add these in, as long as we keep the signs correct. So we'll end up with minus 2 on 2, which gives us overall negative 1. Cool, so we've got the x value for the turning point. Now we need to find the y value for the turning point. To get the y value for the turning point, we sub this -1 back into our original equation. So we'll get y is equal to -1 squared, making sure we square all the negative sign as well as the 1, plus 2 times -1 minus 35. So when we do this, we get 1 minus 2 minus 35 gives us -36. So our turning point is at -1 minus 36 overall. Next thing we need to find, and it's a bit easier, we need to find the y-intercept. So the y-intercept happens when x is 0. So let's just substitute x is 0 into our original equation and see what we get. Well, we'll get 0 squared plus 2 times 0 minus 35, which is just going to end up giving us minus 35. So this is our y-intercept, y equals -35. Now we need to sketch this. When I'm doing these, and you should check with your teacher before you do this, but when I'm doing these, I don't think there's much point in making sure that my graph is completely accurate. The main things I care about are these features that we've asked for, the turning point and our x and y intercepts, as well as making sure we've got the general shape. So making sure we've got a parabola, it's a minimum or a maximum, whichever we need, and making sure that all of our important points are labeled. So I'm going to put my important points on the graph first, so it's easy for me to keep track of them. So here's -7. Over here is +5. We'll have down here, we'll have our y-intercept, -35, and we'll also have our turning point at -1, -36. Now we just need to join them up in a vaguely parabolic shape, and that's it, we're done. Okay, last example, we need to sketch x squared plus x minus 12, showing the turning point and the x-intercepts only this time. So this time we're not being asked for the y-intercept as well. We still do this the exact same way. So we're finding the x-intercepts first. So we set y is equal to 0. We'll get 0 is equal to x squared plus x minus 12. Again, I'm going to skip over the factorizing. We're looking for factors of -12 that add to give +1. That's going to be 4 and -3. So we can say x plus 4, x minus 3. And then by null factor law, we can, because we are currently in factorized form with the right-hand side, with the left-hand side equaling 0, by null factor, x plus 4 equals 0, and x minus 3 equals 0. So x will be equal to -4, and x will also be equal to +3. These are our two x-intercepts. Now we need to find the halfway point between these, and that will give us our turning point x-coordinate. We'll get -4 plus 3 over 2. And when we simplify that, this will give us -1 over 2. And that's it. That's our x-coordinate. Now we have to substitute this back in to our original equation. So our original equation was y is equal to x squared plus x minus 12, which when we substitute this in, we'll get -1/2 squared plus -1/2 minus 12, which will be 1/4 minus 1/2 minus 12, which when we evaluate that will give us -12 and 1/4. So that's our y coordinate of our turning point. So our overall turning point is -1/2, -12 and 1/4. So now we'll sketch this. We've got our x-intercepts, -4. I'll put that one in first, and then +3. And we've got our turning point at -1/2, -12 and 1/4. I'll label these. It's really important that you label these so you can show whoever's marking your work exactly what you've done, that you can to get to where you want it to go. So 3, 0, 4, 0. You can label these as just x equals 4, x equals 3, or you can label them with the point notation like I've done here. And then down here we've got -1/2, -12 and 1/4. Try to write a bit more neatly than I have. Now let's parabolize these together. There we go, there we go. And that's it, all done. So remember, whenever we're doing these, we find the x-intercepts. We use the x-intercepts to find the x-coordinate of the turning point. Then we substitute that into our final answer to get the y-coordinate of the turning point. Good luck, everyone.